All right, so the next lesson is on graphs of what we call sinusoidal functions. So what we're going to do here is just take a look at the graphs of these functions. Right? What you might notice or might be wondering is what about the equations? We're going to look at the equations and how they relate to the graphs in the next lesson. All right, so this is just basically looking at the graphs of these functions without relating it to the equations quite yet, and just kind of picking out some characteristics. All right. So it's just one example today. So this is a graph of a sinusoidal function. So what you'll see is that, it's kind of like a wave graph. Notice that the maximum and the minimum here. Right? So the maximum's up here, the minimum's down here. It's consistent, right? It's the same. All right. So that's one of the key things about these functions. All right, so so it's like a wave kind of graph function. So given the graph of a sinusoidal function, find the following. All right, so we're going to find these characteristics: the range, amplitude, equation of the midline, and period. Okay, so let's start off with the range. Now this range is what we're talking about is the domain and range. So the range in this case, you can see that for this graph, the low point here is -2. So actually, I'll just write -2 here. Right, so that's as low as the graph goes, and then as high as it goes is +4. All right, so in this case, the range here is between -2 and +4. So it's going to be -2 less than or equal to y less than or equal to +4. Okay. Actually, even though it's not written here, I'll actually let's look at the domain. The domain in this case, actually, this function goes on forever. All right, so on this side over here, it'll come back up and then it'll go back down, like so on. And same with on this side, it'll go up. Doesn't let me draw on here. And then it'll come back down in this case. So the domain, if we were to go left to right, there's always going to be a function everywhere. So the domain in this case is all real numbers. However, what the main focus here is the range. Okay, so this function here is between -2 and +4. All right, so that's the range. So the next thing here is called the amplitude. All right, so the amplitude is the distance from the center to the maximum. Or in brackets here, I'm just going to write or minimum. Right, because it's going to be the same distance. So you can't quite read that, but that says minimum. All right, so in other words here, we want to figure out what the distance is from the center to the maximum center to the minimum. Now, you could, in this case, we can probably just count it, right? Because we can see that from -2 to +4, that's a distance of 6 units. So the center itself, we can kind of just eyeball it or just do some quick counting here, and we can see that at +1, this is the middle, right? So if I was to draw a dotted line here, draw a dotted line through there, this is the center of this sinusoidal function. Right? It's going to be 3 units. Grab another color here. So this would be 3 units up this way, and then another 3 units down this way. All right. So the center here is at 1. So therefore, the amplitude is the distance from the center to the maximum, which is 3. But since we're talking about center, it's going to be the same distance as the minimum. All right, so here the amplitude is equal to 3. So that's what I'm going to write here. A is equal to 3. But now what I'm going to do here is just show you an algebraic way of getting it. If, for instance, that let's just say we couldn't just count it. Right? Let's say like the numbers are much bigger. You know, I don't want to spend too much time counting. So another kind of quick formula here is the amplitude is going to equal the maximum minus the minimum divided by 2. All right, so this kind of makes sense, right? So the maximum minus the minimum would be the distance from the top to the bottom. And then if we're dividing it by 2, that would give us half the distance. All right, so this should work out. We're just going to show you how to get 3 as well, just using this formula, right, for this example. So the maximum here was 4. The minimum was -2, so I'm going to subtract -2 over 2. So 4 minus -2 is the same as 4 plus 2, so that's 6 over 2, which is equal to 3. Okay, so when we use this this kind of formula here, you can see that it does give us the amplitude. All right. Okay, cool. Next thing here is the equation of the midline. All right, so we've actually already found the midline. So this dotted line is actually the midline. So it's going to be half the distance from the top, or half the distance from the bottom. All right. So in this case, the equation of the midline, and they say equation because it's a line. So equation of the midline. This is since it's a horizontal line, it's y equals, all right, 1. Okay, so that's the answer to this. Now there is also a formula that we could implement to get it if the numbers aren't, if we can't just count it, right? So in this case, let's see here, midline is basically what you're going to do is you're going to take the maximum, and this time actually it's a different color here. It's different from the amplitude. Instead of subtracting, you're actually going to add the maximum to the minimum and divide it by 2. All right, because and hopefully logically this makes sense. The midline is kind of like the average between the maximum and the minimum, right? Because it's in the middle. So if I was to add the maximum to the minimum and then divide by 2, that should give me the center. So if I apply this to this example, I would go with y equals. All right, and oh yeah, as well, it's y equals because it's a horizontal line. The maximum value here was 5. And if I add the minimum value, which is -2, and then divide it by 2. Oh, sorry, not 5. My bad. Maximum was 4. All right, so the maximum value here is 4. So if 4 plus -2 divided by 2 is the same as 4 minus 2 over 2, which is 2 over 2, which is 1. All right, so you'll see that that is what we got when we just counted to find the middle. All right, so that's the midline, y equals 2, or sorry, y equals 1. Now, the last thing that we need to find is something called the period. All right, so use purple for this one. All right, so to find the period, what the period is basically the length of one cycle. All right, so what I mean by cycle is, notice here that it starts at the top here, and then it goes down and then back up. All right, so this would be the next maximum. The distance from this maximum to this maximum is called the period. Okay, so in this case, yeah, we can just count it here. We can see that the period here is this has a distance of from 0 to 4. So the period in this case is equal to 4, because that's the length of one cycle. All right, so the period in this case is equal to 4. That's simple. All right, and yeah, and what you'll notice is that again, from maximum goes back down, back up to here. This would be the length of another period. And you can see that this would be at 8. All right, so the period is the same no matter what. If I go in the other direction here, notice that this here is at -4. So again, the period has a length of 4. All right, cool. So that's yeah. So that's basically the graphs of sinusoidal functions, picking out these different kind of characteristics. Right? So range, amplitude, midline, period. And that is it. Ciao.